We are right now calibrating the level using bubbler method. Open the valve V3, V5 fully. Remove for temporarily I output from 10 so that control valve is fully open. Make pump on by SW3 so water is flowing both the rotameters into the level column. After reaching 500 mm on level column, adjust AFR2 such that inside the level column not more than 5 bubbles. At the same time, pressure meter should show 500.
Start.
At the same time, level of the DPM should show 500 mm. Ensure 25 pin parallel port cable to the computer interfacing panel. And pump should be on. One valve should be open, remain to be closed. V5 should close. Set the setting windows on PID controller panel as per page number 3-11. Plot the graph using PC based PI controller. Take the graph using set value and measured value. Graph plot. And channel 0 is the measure variable and square wave is your set value. So in this experiment your set value is 40% of 500 mm. That means 200 mm your set value. So your electronics display is showing 200. Level output is showing 200 mm. Control valve is maintain the level from I to P converter giving feedback according to your set point controlled by computer. This is of the proportional integration derivation control with set point change. PB is 10%, TI is 10 seconds, TD is 2.5 seconds. From set point 40% to 60%, once again come to 40%. We can perform flow experiment also in this fashion. Connect the wiring sequence from 4-14 page. proportional integration derivative control with manual change in set point. Connect the patch cords flow output to the channel 0, and same thing you connected to the DPM. Select the LPH position 6 to 9 and I2P to converter to I output to the I2P converter. Pump on by SW3. Set the values in panel as per settings on 4-14. Integration time is 1. Proportional band is 140. Derivative time is 0.08. Derivative gain is 10. PID action reverse. In settings, select channel 0 measured variable. Select source of set value from FG square wave output. Frequency should be 0.03. Amplitude should be 50. Minimum value 0. Maximum value 100. Unit is percentage. Square root law should be applied for the channel 0. That depends on setting of measured variable. If you select channel 1, you have to select the square root law by channel 1. Ratio factor should be 1. And then OK. Then auto. Then save. Then yes. Then graph. Then PC based PID controller. PC based PID controller. Then set value. You have to see the graph from set value versus measured variable, not any other factors. And then graph plot. So your set value is changes from 30% at the to 75%, 25 to 75% follows as per square wave. So FG square wave measured variable is follows the FG square wave. Measured variable here the flow output. Standalone PID also without using computer. This PID is control valve. The output is 4 to 20 milliampere. Measure variable should give the from patch cord number 1 and common. This requires external power supply. Power supply should be on. The 4 to 20 milliampere output goes to I2P converter. So measure variable goes to measure variable of any signal condition circuit, level or flow, that depends on your experiment. You can see the graph using the PC by serial port also. You can just set the set point measure variable as per the manual. So connect the patch cords as per wiring sequence. Measure variable of level is controlling by PID.
Because if I give these kits to students, rather than lab is to give the student, he should feel कंफर्टेबल, अरे आराम से बैठे एंजॉय करे स्टूडेंट